Welcome to this presentation on microprocessor-based control. Hopefully, after this course, you will understand what a microprocessor is, what it does, and how it works. Understand the concepts of RAM and ROM computer memory, and how memory is accessed via the address and data buses. Understand how parallel and serial data interfaces work. Perform relevant calculations pertaining to analog to digital converters and digital to analog converters. Understand the principles of digital control software. Recognize and describe the characteristics of the various types of available digital controllers, that is, microcontrollers, single board computers, programmable logic controllers or PLCs, and personal computers. The microprocessor has ushered in a whole new era of control system electronics. The revolution has occurred because the microprocessor brings the flexibility of program control and the computational power of a computer to bear on any problem. Automatic control applications are particularly well suited to take advantage of this technology. And microprocessor-based control systems are rapidly replacing many older control systems based on analog circuits or electromechanical relays. One of the first microprocessor-based controllers, made specifically for control applications, was the Programmable Logic Controller, or PLC, which is discussed later in this presentation and again in Chapter 12. A microprocessor by itself is not a computer. Additional components such as memory and input and output circuits are required to make it operational. However, the microcontroller, which is a close relative of the microprocessor, does contain all the computer functions on a single IC. Microcontrollers lack some of the power and speed of the newer microprocessors, but their compactness is ideal for many control applications. Most so-called microprocessor control devices, such as vending machines, are really using microcontrollers. Some specific reasons for using a digital microprocessor design in control systems are the following. Low-level signals from sensors, once converted to digital, can be transmitted long distances, virtually error-free. A microprocessor can easily handle complex calculations and control strategies. Long-term memory is available to keep track of parameters in slow-moving systems. Changing the control strategy is easy by loading a new program. No hardware changes are required. Microprocessor-based controllers are more easily connected to the computer network within an organization. This allows designers to enter program changes and read current system statuses from their desk terminals. In this series of presentations, we will present the basic concepts of a microprocessor and microcontroller-based system, with particular emphasis on control system applications. It is by no means an in-depth treatment, but enough to make the rest of the text more meaningful. In the first sections of this course, the basic concepts of microprocessor hardware and operation are introduced, as the student of modern control systems should have at least a general knowledge of how the microprocessor performs its job.